Today, I'll be showing you how to set up synchronization between two Pi-holes. Previously, I showed you how to set up a Pi-hole instance on a Raspberry Pi in under 20 minutes. But aside from the only thing better than Pi being more Pi, why would we want two instances of Pi-hole in the first place? That's a good question. Pi-hole is a pretty stable piece of software. Unbound is too. And Raspberry Pis are pretty reliable. Stuff still happens though, and in the case of any of those pieces failing, you can be left without the ability to use the internet from your LAN. If you have your wits about you, you can just change your router's DNS setting back to quad 9 or whatever. In my opinion though, the better solution is to have a setup that doesn't require you to do anything. And for that, you just need to have another instance of Pi-hole. You can either have this other instance on a different Raspberry Pi, with you just having to follow the instructions from the Pi-hole video again, except you're a pro this time. Alternatively, you can have the other instance on Docker, Proxmox, or even some routers. Then, you'll modify your router's DHCP settings to include the second Pi-hole's IP address as a secondary DNS server. Voila. So easy. Wait, if all you had to do was follow the previous Pi-hole video 2 times, why did we need another video? I'm glad you asked. Because even though you now have redundant Pi-hole instances guarding against a failure, those instances are independent with separate configurations. You can manage this manually, but that's a pain. In 5 minutes, or less, you can set your primary Pi-hole to replicate from the primary at regular intervals. Welcome back to Dad Explains Everything. Recently, I explained the levels of DNS filtering, from on-device setups to router-level filtering to network-wide solutions. And in that video, I promised a full walkthrough of the self-hosted Pi-hole option. After that video, people wanted to know how to make it bulletproof and ultra-reliable. So here we are. Today, you're going to load Nebula Sync on the primary Pi-hole, configure the secondary Pi-hole to allow API control, configure Nebula to sync from the primary to the secondary instance, create a time job that calls Nebula Sync, and verify Nebula Sync works with a manual launch. So if you don't have a second Pi-hole instance, you're going to have to wait until you have one. I mean, you're welcome to watch this video regardless, of course. I'm going to assume that both instances are on Raspberry Pis. You'll have to make some adjustments if one or both are not on Raspberry Pis. If only one of your instances is on a Raspberry Pi, I think it's a good idea to have that one be designated as the primary. Also, if you have mismatched Raspberry Pis, like a Raspberry Pi 4 and a Raspberry Pi Zero 2, I would designate the better Raspberry Pi as the primary. Before the train leaves the station, I do want to mention that this tutorial isn't going to be appropriate for anyone that decided to use the DHCP server built into the Pi-hole. It's not that you can't do that, but it definitely makes it more complicated, as you can't have more than one DHCP server at a time on a subnet or VLAN. If you do want to know how to make the DHCP servers fail over gracefully, including the DHCP leases and reservations, let me know in the comments. Alright, with that out of the way, let's get started. Per usual, there's a worksheet. Don't worry, it's short, but you'll want to do the usual. Print it and write down the information requested, and copy-pasting the commands and configs as they come up from the worksheet directly. The link is in the description below. Step 1. Who is leading this dance? I already touched on this, but you'll need to designate which Pi-hole is primary and which is secondary. Generally, you'll also list the Pi-hole addresses in your router or network clients in this order too. You'll note the primary and secondary instances with their host names and IP addresses in your worksheet. Step 2 is prepping the secondary Pi-hole. Hopefully, you still have the worksheet from setting up your secondary Pi-hole, because you'll need a couple pieces of information. I'm assuming you've already gone through the Pi-hole installation video, so you should remember how to SSH into your Raspberry Pi. As a reminder, you'll need to open a terminal window. On a Windows computer, you press the Windows and R keys. When the run prompt comes up, you'll type in CMD and press enter. A command prompt window will appear, and in it you will type in SSH followed by a space, then the username from step 1, number 6 on your old secondary Pi-hole worksheet, an @, and then the IP address from the end of step 1 on the same worksheet. It will look something like this. You'll be prompted for a password, and you'll enter the one that you created in step 1, number 6. After that, you'll copy and paste and execute the following statements one at a time from the worksheet. Alternatively, this can also be done from the secondary Pi-hole's web admin. That's all we're going to do with the secondary Pi-hole. Step 3 is downloading and installing Nebula Sync. Since it's in a code repository that changes, I don't want to link you to a version that will go out of date. To handle this, you will copy and paste and execute the following statements one at a time from the worksheet. If you're feeling a bit adventurous, you can copy and paste them as a block, and they will execute sequentially. It's a little harder to see the output from each of the statements, but it's definitely more convenient to execute them in bulk. Step 4 is to create a directory, and create a Nebula Sync configuration file in the new directory. You will copy and paste and execute the following statements one at a time from the worksheet. You'll copy and paste the configuration from the worksheet too, changing the IP addresses of your primary and secondary instances and changing the passwords to what you had at the end of step 4 in the original Pi-hole setup worksheets. If you copy and pasted the set password line as is, your passwords may also be set to Pi-hole. You'll then save the file and exit Nano. Step 5 is to create the service file. You will copy and paste and execute the following statement from the worksheet. You'll copy and paste the Nebula Sync service block from the worksheet, changing the user from netserve to what you had at step 1, number 6 on the original Pi-hole setup worksheet. You'll then save the file and exit Nano. Step 6 is to create the timer file. You will copy and paste and execute the following statement from the worksheet. You'll copy and paste the Nebula Sync timer block from the worksheet. You'll then save the file and exit Nano. We'll then activate it by copy, pasting, and executing the following statements one at a time from the worksheet. You can manually test Nebula Sync by copy, pasting, and executing the following statement. You can run this command to see if you have any errors. To see if it actually synced anything, you can make a configuration change on your primary and see if it propagates to the secondary. With any luck, you have 2 Pi-holes now, with the secondary syncing its configuration every 15 minutes. If you ran into an issue, it's likely the IP addresses, the username for logging into the Raspberry Pi, or the passwords for accessing the Pi-holes via API. As always, I'm here to help, so let me know if you ran into any issues in the comments. This video isn't very long because this task isn't very hard. And at this point, if you started off a novice, you're getting to the point where your skills are increasing. Maybe we can take on a more ambitious project next. Let me know what you think about that and what you want to add to your Raspberry Pis. And with that, congratulations. You now have the type of redundancy that professionals put in place for critical network services. If you found this video interesting or helpful, hit like, subscribe, and share this with anyone else that you think hates ads too. If you want to support my work, please hype the video and consider becoming a member. I'm not a big deal, so it's really cheap. Depending on the tier, we can hang out on Discord, so there's that. And while I hate to ask for money, these videos take a surprising amount of time to make, and the more specific they get, the fewer people watch them. And speaking of members, I want to thank new members Cactus, Legros, 90s Hip Hop, Bernsey, AJ, Michael, Daniel, Just One More Time, Ralph, Andre, and David for their support. And just to let you know, the Raspberry Pi raffle happened. The winners need to claim their prizes. Please see the results link in the description below to see if you won. Thanks, and have a great high availability day.